Standard 9, Chapter 8, Trigonometry. In the first picture, I want to calculate the height of this tree. So how am I going to calculate this? Similarly, in the second picture, there is a lighthouse on the seashore and a ship is sailing on the sea. If I want to calculate the distance of the ship from the lighthouse, how am I going to calculate it? This is surely one of the difficult thing to find out. To find out the answers to all this, we see trigonometry. Trigonometry is used to measure the height of the tree and to measure the distance of the ship from the lighthouse. Trigonometry is a branch of mathematics used to find the distance and the height of the objects. Trigonometry is derived from three Greek words: tri means three, gona means sides, and metron means measurement. Trigonometry is basically the measure of three sides. Any geometrical figure which has only three sides or three angles is a triangle. So trigonometry deals with the study of triangles, basically right angle triangles. Let us see where is this trigonometry actually used in real life. First, it is used in navigation. In navigation, it is used to find the distance of the shore from a point in a sea. In oceanography, it is used to calculate the height of tides in the oceans. It is used in astronomy. In astronomy, it is used to find the distances to nearby stars and other celestial objects. In engineering, it is used daily to calculate angles, to build bridges, buildings, etc. Let us revise some basic things which we have studied in the previous classes, that is right angle triangle, Pythagoras theorem, and similar triangles. First, let us study about Pythagoras theorem. Pythagoras theorem is based on right angle triangle. So, in triangle ABC, angle B is a right angle and side opposite to angle B is AC and is called as hypotenuse side. Side opposite to angle A is BC and side opposite to angle C is AB. So by using Pythagoras theorem, we get one side square plus second side square is equals to hypotenuse square. So as you know, in triangle there are three sides. So one side is AB square, second side is BC square, and the hypotenuse side will be AC square. Hypotenuse side is always the side opposite to right angle. This was about Pythagoras theorem. Now let us see about similar triangles. Similar triangles are two triangles which look similar but actually they are not similar. That means their angles are same but their sides are different. So now in triangle ABC and triangle DEF, angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F, and their sides are in proportion, which means AB upon DE is equals to AC upon DF is equals to BC upon EF. Then triangle ABC and triangle DEF are called similar triangles and they are written as triangle ABC is similar to triangle DEF. For similar triangles, there are two conditions. So, both the conditions should be satisfied for the triangles to be similar. Now, let us do one activity based on similar triangles. With the help of similar triangle property, we are going to find out the height of this tree. Name the height of this tree as QR. Take a stick and name the height of the stick as BC. Thrust a stick in the ground as shown in the figure. Measure the height of the stick and the length of its shadow. Measure the length of the shadow of the tree. We know that rays of sunlight are parallel. Hence, both the triangles will become equiangular, which means their angles will be same. That means they are similar triangles. So if their angles are same, then their sides are in proportion. So we get QR upon BC is equals to PR upon AC. Hence, we can also write as QR upon PR is equals to BC upon AC. When we rearrange this, we get an equation height of the tree as QR, which is equals to BC upon AC into PR. We know the values of BC, AC and PR. When we substitute those values in this equation, we get the height of the tree. Accordingly, by using similar triangles property, we can find out the height of the tree. Now, let us see the terms related to right angle triangle. First, let us draw a right angle triangle and name it as A, B and C. Angle B is 90 degree. So the side opposite to 90 degree is called as hypotenuse side. So here hypotenuse side is equals to AC. Now in right angle triangle, if one angle is 90 degree, then the remaining two angles will become acute angle. So angle A and angle C are acute angles. Among those two angles, if I consider angle A, BC will be the opposite side of angle A. Then AB will become the adjacent side of angle A. Adjacent side means the neighboring side of the angle which we have considered. Now, if we draw the same triangle and we consider angle C, hypotenuse side will be the same, that is side opposite to 90 degree angle. But when I consider angle C, the opposite side changes. So AB will become the opposite side of angle C. Then BC will become the adjacent side of angle C, which is the neighboring side of the angle I have considered. These three terms are important for the entire chapter. Now let us study about the trigonometric ratios. First, let us draw a right angle triangle and name it as A, B and C. There are total six trigonometric ratios, that are sine, cos, tan, cosec, sec and cot. But here first let us learn three trigonometric ratios, that are sine, cos and tan. Now let us consider angle C first. So the sine ratio will be sin C is equals to AB upon AC. What is AB of sin C? It is the opposite side of angle C. And what is AC? It is the hypotenuse side. So sin C will be opposite side upon hypotenuse side for in this triangle, which is AB upon AC. Now cos C will be BC upon AC. For this triangle, BC is adjacent side of angle C and AC is the hypotenuse side of angle C or the entire triangle. So the ratio of cos C will be adjacent side upon hypotenuse side, which is BC upon AC. Tan C is AB upon BC. AB is nothing but opposite side and BC is nothing but adjacent side. So the ratio of tan is opposite upon adjacent. In order to remember these trigonometric ratios, there is a shortcut, which is SO, Ka, TOA. So S stands for sine ratio, O stands for opposite side, H stands for hypotenuse, Ka, C stands for cos, A stands for adjacent, H stands for hypotenuse. TOA, T stands for tan, O stands for opposite side and A stands for adjacent side. So to remember it, it should be SO, Ka, TOA. These are the some instructions to study trigonometry. That are, in trigonometry we use right angle triangles wherein one angle is 90 degree and remaining two angles are acute angles. Second point is, sometimes measures of acute angles of a right angle triangle are represented by using Greek letters theta, alpha, beta, etc. So sine ratio we have studied is opposite side upon hypotenuse side. Cos ratio is nothing but adjacent side upon hypotenuse side. And tan ratio is cos opposite side upon adjacent side. These are the three ratios which are very important in this chapter. The remaining three ratios, that is cosec ratio, sec ratio, tan ratio, are based on sine ratio, cos ratio and tan ratio only. So to study those ratios, we need to learn these ratios first. Practice set 8.1. First question. In the figure, angle R is a right angle of triangle PQR. Write the following ratios: sin P, cos Q, tan P and tan Q. First, let us draw a triangle and name it as PQR. So as you can see, angle R is a right angle. Solution: sin P is equals to opposite side of angle P upon hypotenuse side. So opposite side of angle P here is QR and hypotenuse side is PQ. So the ratio of sin P is QR upon PQ. Second, cos Q. The formula for cos ratio is adjacent side upon hypotenuse side. So cos Q is adjacent side of angle Q upon hypotenuse side, which is QR upon PQ. So cos Q is QR upon PQ. Third, tan P. Ratio for tan is opposite side upon adjacent side. So tan P is opposite side of angle P upon adjacent side of angle P, which is equals to QR upon PR. So tan P is QR upon PR. Tan Q is opposite side of angle Q upon adjacent side of angle Q, which is equals to opposite side of angle Q is PR and adjacent side of angle Q is QR. So tan Q is equals to PR upon QR. Now let us solve the second question. Second question says, in the right angle triangle XYZ, XYZ is 90 degree and A, B and C are the lengths of the sides. Write the following ratios, that is sin x, tan z, cos x and tan x. Let us begin with the solution. First is sin x. So the formula for sine ratio is opposite side upon hypotenuse side, which is equals to opposite side of angle x upon hypotenuse. So opposite side of angle x is yz and hypotenuse side is xz. So the value of yz is A and the value of xz is C. So sin x will be AC, A upon C. Next is tan z, which is opposite side of angle z upon adjacent side of angle z, which is equals to xy upon zy, which is equals to B upon A. Next is cos x. Formula for cos x is adjacent side of angle x upon hypotenuse, which is equals to xy upon xz. So the value of xy upon xz is B upon C. And the last sum is tan x. Formula for tan x is opposite side of angle x upon adjacent side of angle x, which is zy upon xz, which is equals to A upon B. So these were the two sums based on the things which we have studied, that is opposite side, hypotenuse side and adjacent side, and sine ratio, cos ratio and tan ratio. Thank you.